uh, there was some technical issue with the last stream. I mean, the last stream that I tried to schedule like 1 minute back. But we are back, and so what I was saying was, I was like a couple of hours ago, we were doing some. So if we check the docs, right? Our next goal was to get water droplet moving down, right? And this was like a bit like, now if you think, it was kind of long back, and now we are stuck understanding frame buffers. So I thought we should try. We should not try. We should understand frame buffer, but we shouldn't be beating ourselves up. That is not the intention here, because that will not serve the purpose in the long run. So we should be aiming to understand frame buffer, but we will do it enjoying as much as possible. But I'll try my best to understand this and implement this before the stream ends, or continue streaming until I understand this. This is not a like promise, but I'll try my best. So yeah, we were reading an article beforehand, if you guys remember, and there is no one as of now, but there might be a future audience, hopefully. So for those, if you guys remember, this is not a we will maybe recap that part. So basically, we understood that there are multiple types of frame buffer is just like a struct that actually encapsulate multiple types of buffers and a texture. And the types of buffer include color buffer, depth buffer, stencil buffer. And these are all types of render buffer basically. And now what we were looking at is, going through some code here, and we were coming up with couple of commands. GL text image 2D. We have kind of similar command in OpenGL and GL frame buffer texture 2D. Now, in case of GL text image 2D, it is basically associating. So we create a number, right? Which is the generated texture. It just creates a number. We pass it an array index, and it actually changes the number. After which we bind this number to GL texture 2D, which is basically saying that this number is of type GL texture 2D. And the third thing that we do after that is we load the bitmap. We have decoded, we took the image resource and we decoded it, and we made sure that it is getting loaded, that bitmap is getting loaded to our main memory using text image 2D, GL text image 2D command. After which we came across this GL frame buffer texture 2D, and this is for attaching a texture to a frame buffer, right? So we have established that the OpenGL recognizes and has in its main memory texture, right? Along with its texture, along with its number identifier, which is basically a number. And then now you pass this to the frame buffer. Now you have created a frame buffer parallelly, and then now you just say to the frame buffer, hey, this number that we created, right, which is associated with the texture, is now part of this particular frame buffer. It will be an attachment to this particular frame buffer. We were at this point of reading this article when we closed the last stream. Now we'll go back. I think we have to see that bad rendering now. Yeah, this is some hopeless rendering that is happening now. OBS, this OBS issue, laptop issue, I'm not sure. Uh, so yeah, we had read all this, right? As in, we can't use our frame buffer yet because it is not complete. For a frame buffer to be complete, the following requirements have to be satisfied, right? We have to attach at least one buffer. There should be at least one color attachment. All attachments should be complete as well. Each buffer should have the same number of samples. Okay, that we are not attaching multiple samples, so multiple buffers. So yeah, that is fine, I guess. And yeah, checking this is the binding buffer. So binding frame buffer, generating frame buffer, we are already aware of all this. Now we will go to the yeah, we are loading something else called. So there are two things that is happening, right? One is in our case we just assigned a bitmap, right, in GLTeX image 2D. In that case, it is not assigning a bitmap. This is one of the differences, I would guess, right? It is just saying it is null. GLTeX image 2D is null, right? There is no bitmap associated with it. Maybe this is to indicate that there is nothing now, but after the OpenGL processing, we will be able to get something there. Maybe that is the reason. But I'm not sure how a similar operation would be done on Android because uh, yeah, I'm not sure actually. Um, if this is the input and this is the output as well, then also the things should be fine, right? As in, even if we provide a data there, it should be fine, right? As in, so as a parameter, we provide the texture as well as if we attach the texture to the frame buffer, will that also work? I'm not sure. We are already passing it as a parameter, but if this happens to be the um, output as well, will that work? I'm not sure. Okay, we will explore that part. But here we are again adding something else as well. There is some other attachment called stencil attachment. Let's just assume that this is doing the same stuff as above, but instead of color attachment, it is showing stencil attachment. Everything else remains same, I guess. Uh, now, yeah. Now render buffer object attachments. Render buffer objects were introduced to OpenGL after textures as a possible type of frame buffer attachment. Just like a texture image, a render buffer object is an actual buffer. Render buffer objects were introduced to OpenGL after sense of urgency. I'm catching myself spacing out one and yeah. Um, yeah, today I was trying some other approach, right? I was trying to understand the content from Coursera offline and then maybe use that and then have a fasten up this process here. By the way, I will link to that content. That is good content. But there also I was taking time, so I thought I will anyway understand this over the fly and not get sidelined because I'm too much into structured courses as well as in I believe structured courses are required at some point at many places, but sometimes you just for a particular purpose you need not understand everything, right? You need to have abstract away many things sometimes, which is good for speed. It is good. So you need to somehow find a balance of that. So yeah, currently this is fine. Render buffer object attachments. Render buffer objects were introduced to OpenGL after textures as a possible type of frame buffer attachment, just like texture image render buffer. An array of bytes, integers, pixels, or whatever. Our render buffer object cannot be directly read from. Okay. This gives the added advantage that OpenGL can do a few memory optimization. Okay. But are we interested in render buffers here? I don't think we should be interested in render buffers, right? We will directly make do with textures. Maybe it has a performance advantage, but we have to read the data as well, right? Okay, why are the slow read GL read pixels? Yeah, but I don't think render buffer is required for us as of now, at least. But the code itself is quite similar actually. Generate render buffer, bind render buffer, and GL render buffer storage. So this is basically GL render buffer storage is basically your GL text image 2D, right? Here we are not passing any memory because of course there is no pointer here. But also in bind render buffer, yeah, of course there is no pointer here because there is no bitmap that we are loading, right? So that is why we just have to specify this and you just then frame buffer render buffer, right? Okay, so basically the process is quite similar to the texture thing. First you create the texture, just like texture number, this render buffer number. Then you associate it with a type of render buffer, right? This depth 24 with a breadth and width. This is just as discussed similar to text image 2D. After which we are actually attaching this render buffer to a frame buffer, which is very similar to what we did with texture. Yeah, great. See, there are the general rule is uh, we can note this down. General rule is if you need to sample data from a specific buffer like color or depth values, you should use texture attachment instead. So if you never need to sample data, we definitely need to sample data, right? As in the rendering to a texture post process. What were we doing? Yeah, we have to put this in the doc. That was a spacing out thing, by the way. Render buffer is faster, else texture is fast. I think we have noted it down. We'll get back to the article. Okay, finally we are here rendering to a texture. Now we will understand how we are going to render to a texture directly. This is going to be interesting. Now that we know how frame buffers work, it's time to put them to good use. We are using to render the scene into a color texture attached to a frame buffer object we created, and then draw the texture over a simple quad that spans the whole screen, which is exactly what we want to do, right? Which is exactly what we want. If this happens in one go, I think I can sleep early. But things won't be that easy. Things definitely won't be that easy. OpenGL ES would not allow all this to happen that fastly, right? I mean, we started out wanting to animate water droplets. Now we are stuck understanding frame buffer. So yeah. But yeah, let's go through this. First thing is to do is create an actual frame buffer object and bind it. Okay, this is pretty evident, pretty straightforward. After which, what is texture color buffer? Okay, which is just the number. Okay, and we just did a null and all that. Okay, then this GL text parameter, GL text. Okay, GL bind texture. Okay, so this is all explained above. This is pretty much the same thing. We associated with the we associated things with the frame buffer. We generated the frame buffer. We associated things with the frame buffer. Now, okay, this is sidetracking. This is a sidetrack that we are not bothered about. Okay. Okay. What? I didn't understand at all. Be sure to unbind the frame buffer to make sure we are not accidentally rendering to the wrong frame buffer. Okay. Now that the frame buffer is complete, all we need to do to render to the frame buffers, frame buffers. Instead of the default frame buffers, is to simply bind the frame buffer object. All subsequent render command will then influence the currently bound frame buffer. Meaning, render the scene as usual with the bind the default. Draw a chord that spans the entire screen with the new frame buffers color buffer as its texture. Okay. What did they do now? This is all text cards, physical records, GL position frag color. This is all pretty. This is nothing too fancy. It is actually very true. Uh, okay. Okay. Texture color buffer. Okay. So this is what is happening, right? We did a draw scene, and then in the second pass, that texture color buffer is acted upon as the input to this. Great. Texture color buffer is what, by the way? Okay. Texture color buffer is the texture only. Is that it? Have you understood everything? What are kernels? So basically, now I understand what I understand is to draw the scene, then after which you come back to default, then you do clear color. Okay, whatever you have to do. This is the second pass. And you just render this, whatever is this. And this seems pretty straightforward. So we might have to write a couple of more shaders maybe, but this seems pretty straightforward. Should we draw? Is it time for some Eureka music? Because the texture attachment that happened during uh, the initial thing acts as the input for the second pass. That seems pretty simple. Seems. Keyword is seems. I think there is some kind of example of this that is happening in that Stack Overflow code as well. Yeah, I think some sort of similar thing is happening in the Stack Overflow code as well. Is there an incremental way of testing this? I don't think there is an incremental way of testing this. I don't think we just writing it out to a frame buffer, some frame buffer can be tested. It can only be tested once it is rendered again. I think we can initialize both the programs in the init itself. Then one after another, we can take it anyway. So there is no issue there. This seems pretty interesting actually. And straightforward also. Maybe we can do with some Eureka music. Where is my... Eureka music should be something happy, man. Yesterday's music was... it should be good day, man. Good day. And this...
Step one, wake up early, gonna rise with the sun. Step two, get some good, some food in you. Step three, think real hard about what you wanna be. Step four, everybody just do your thing.
Wake up, today's gonna be a good day. 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 Yo. Set your affirmations, aspirations. I got shit to do, the aftermath of preparation. Good food, good mood, blood in circulation. One step at a time, yeah, that's how you make it. Set a goal you control and the steps you take them. I try to pick one thought, have some concentration. And if I make a mistake, it's called education. I try to do this every day, call it replication. Wake up, today's gonna be a good day. 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 So life ain't easy, yo, I think there's a reason though. Ups and downs, just like every different season, yo. Sometimes I'm high, other times I'm barely breathing, though. You always gotta fight and hide from the demons, yo. Negative thoughts are poison, they rot. Head full of flaws, so here come the clouds. They'll never stop unless I can swap all the bad for the good in my head when I'm lost. Yeah, so I'ma fake it till I make it. Positive thoughts are overtaken, I got patience. One day at a time is how you operate a cadence. A flow, you grow, you show yourself a foundation. Stay away from all the shit that causes temptation. I know that I like to do it cause it's sensation. I live my life in my head like a narration. Don't expect greatness, do my best, man, I'll take it. Wake up, today's gonna be a good day. 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 Wake up, today's gonna be a good day.
Wake up early, gonna rise with the sun. Step two, get some good, some food in you. Step three, think real hard about what you wanna be. Step four, everybody just do your thing.
Yeah. It's done. I was dancing to it, so it's a bit of an early dance, but anyway, it's fine. At least we got through the article and we got the main idea of the article, at least what we are supposed to do and what is kind of possible, right? We were confused with a lot of things, right? So we were kind of thinking about many things. So I think at least the algo is kind of known, right? We have to draw it to a texture and then we swap the buffers and the buffer yeah, so let me just write it down. I think that is the only way sometimes. I'll go for using frame buffer. Hmm. What is the algorithm to using frame buffer? Attach and do a control B. Attach frame buffer. Create frame buffer. Attach frame buffer. Create frame buffer. Attach frame buffer. Attach texture frame buffer. Do manipulations on the texture. Swap the frame buffer to and store the output on texture. By default is written on the texture. Kya? What was the shader code there, by the way? Shader code had nothing fancy, right? This is simple shaders, but how do I, for the frame buffer, how do I, so this is for the frame buffer, what is the shader code? Yeah, I'm not sure what is the. Only thing I'm confused, what I'm confused is how does the shader code in the texture rendering know where to render to, right? As in, we specifically specify that, or if there is only one attachment, it by default writes to that. Maybe that is what is happening. There is only one texture attachment, right? It will by default write to that. We can assume that now. Because there is nothing else in that, where will it write to? Right? Okay. Yeah, I think that is how it is going to be. Yeah, that seems to be correct. Yeah, this seems correct, I guess. Now let us try and do this in our code. We'll do first a sanity check, then we'll move forward. So what are the steps that we need to do as far as I can remember, right? We'll just note it down. Swap the frame buffer to opengl frame buffer. Render with input and render. Now, so let us see what we are supposed to do now. This is out of, we are not checking the, what is that called? Um, Stack Overflow code. We'll just directly do this and then see what happens after that, right? So add new shader code, add new program, bind an output texture and input texture to initial pipeline. For second pass, initialize everything and draw. Yeah, this is the main things I think we have to do. Let's see. I need a minute's break. So yeah. This is my BRB. One sec. I'm not able to find my BRB. Yep, I found. Yeah, this is the Eureka index. So, okay, so BRB has to be this. Oh, yep, I'll be right back. I'm back. Just needed to get up and walk a bit and then okay. Also, we had a eureka moment, so a small uh, happiness, sense of happiness after that. Now I'm back. Uh, Man, this is so hopeless, man. This is so hopeless. Yeah. So I think we can now move towards actually coding this up. Textural per I had written so much the code as well. But anyway, let's move towards writing this code. Uh, Body is paining, man. I'm spacing out. I'm making excuses. This is fun. The concept itself is. This is not the actual body pain. This is actually the difficulty of understanding a concept. Or even now in this case, just you might understand more things once you start implementing it, also, right? So find all sorts of excuses to make sure that the brain, all sorts of excuses to make sure that the brain doesn't have to work, right? As in, M texture program. We'll do start with this first. What we will do now, we'll have two sets of shaders. One, this code is bhayanak. I think this can be the second shader. First shader would be simple stuff. The code itself is actually very terrifying, man. It's actually very terrifying. But let's just copy paste it and rename it. Buffer fragment shader, buffer vertex shader. That seems fine. Fragment shader will copy and paste it here itself. Buffer fragment shader. Text, okay. And then buffer vertex shader. Okay. We have two shaders now, buffer vertex shader, buffer fragment shader. Two sets of shaders now. One is for the initial and second is for the final one. Okay. And now the code for the both can be same. That is also fine. For the buffer fragment shader, we might let it be same, no? It doesn't change anything. I mean, we'll change this at the last point. I mean, this can be our last concern. It need not be, we need not be concerned about this beforehand. texture program int, and then we'll just man we'll just add buffer keyword before this. Buffer vertex shader code. Buffer fragment shader code. Then buffer vertex shader. Buffer fragment shader. Buffer vertex shader and buffer fragment shader. Yeah, this is fine, I guess. We have created a program, and but we need text buffer and all that. Even for the case of there needs to be vertex buffer in both cases, right? As in both cases, we are doing the same thing only, but do we allocate different spaces for both? I don't know actually. Uh, we should, right? What does frame buffer do? Okay, this is the one. This is the actual frame buffer. Okay, sorry. We need to segregate the code as well, I guess. The initialization part segregation for both the passes and the yeah, we need to segregate the code, right? Then only this would be correct, I guess. And I have issues with there is in when you start working on, and I should make some sort of I should create some sort of a repository out of this, which is also not done till now. Otherwise, I would have been more confident after committing a working version and uh, then working on this. But anyway, now no point in saying that. It's like such a big undertaking, man. As in, it's as if I'm going to hand me the frame buffer is going to be handmade by me. I'm not sure why I have such a phobia when I start working on something after that is in already in between working state. We'll do step by step. We'll make sure first, let's make sure that the parameters would be same in both cases, right? At least. Yeah. I think we can segregate both the code. Otherwise, I'll get some sort of phobia. Here also, I guess. I have some sort of phobia. I don't. I'll get. Should be easily removable. We can make this work later for sure. So this we can do that later. Usually, what I do now. Usually, when I'm coding alone, I just seep into this. As in, I know I have a bit of a panicky thing when I get to this particular state. So usually I relax and then we should also do the same thing, right? I think no talking and maybe some music. I need not lie on music in the uh, yeah. I need not narrate everything, but I should do these steps. And this is quite evident, right? What needs to be done. We'll just do it in one shot. We'll do the same thing as we are doing for the other buffer, other pipeline, but we'll segregate the code, right? And we'll do it. And we'll put buffer prefix just in case. And make sure that we can easily delete this as well. State size, and this is not required, I guess. Texture program. What is texture program? What did I delete now? Buffer program, right? What is texture program? Was it? I should put buffer, man. Buffer program. Everything is buffer. Frame buffer would have been nice, but buffer is fine, I guess. Texture buffer, state size buffer, frame buffer, buffer vertex buffer, buffer texture buffer. I think I need some music, man. It's okay, right? As in, I'm not going to do anything special. It is going to be a lot of manual. Or maybe I should do it offline. But if I do it offline, no, then what is the point, right? A lot of coding can happen offline, but that doesn't make any sense, I guess. And also, I won't code offline also. To become painfully slow. Already, with sense of urgency, I'm painfully slow. Imagine without the sense of urgency. We have reached the 1 hour mark. Yeah, okay. Kudos. Kudos to that. Uh, this is initial inertia, man. This is initial inertia. Okay, we'll not do everything. We'll just do, but we have to associate all these variables and all that, man. What is this bind attribute location? What is a bind attribute location? You can check that first. You have to put the same coordinates only. Man. I'm so interested in stuff. I'm like, I've done my fair share of stream today for the day. But this would be, no, see, this is, let me, we did a couple of hours streaming today, which is well and good. I was never hoping to do that. But see, already we are on the fourth day, and we are still figuring our way around buffers. And now, after suppose we figure our way around buffer, now there are more things to be handled. There is an actual model that we need to work on, the water model. And I mean, there is a collision that needs to be worked on. I mean, it will stretch out to I don't know how long. It will never end. I don't know how to cope with this then. If I'm not able to, what we'll do now? We'll do everything very fast, very urgently, right? This is an urgent with a sense of urgency. If it doesn't with and if this doesn't happen with a sense of urgency, we'll then take it up tomorrow, right? But we'll first complete the code, right? We'll take out all the decision, cut. Then in the end, we can change those decisions, right? That is the only way to go about, I guess. Let's do that then. What is happening in case of this code, which is the Stack Overflow code? What was that magical command? Text image 2D, right? GL text image 2D. Man, how can I use this command, man? I don't see this at all. Oh, this is directly using that, not the GL utils one. But then how is he using the texture? Is he using any sort of texture then? This is exactly what is happening here. I, the person, actually want to so complete this today. My mind is like, not today, man. What? We already had a eureka moment and all that. Such a battle this is. Uh, what I'll say, no, I'll just code it offline. I think I need some. I'll just code it. Is that okay if I code it offline? There's no one to say no, also, right? I'm streaming to zero audience. I feel I need some music and all that, right? I need some I need some space. And this is my mind is such a you have to convince him to do stuff, man. This is like okay, what we'll do now, we'll do a toss. If it comes as heads, or we'll use some numbers, right? We'll take decisions like that. Yes, right? One to ten, right? If it's 1 to 5, I'll do off stream. If it is 6 to 10, I'll do on stream, right? 1 to 5 off stream, 6 to 10 on stream. I'll do it off stream. I got my excuse as well. But the general steps are quite evident, right? As in, we would have to, but I made a promise as well, right? I didn't like make a hard promise because I knew this time would come. So it's a bit late also. I'm finding excuses now. Yeah, I think I'll do it offline anyway. Random number generator also said this. Yeah, but if that doesn't happen, then I'm not going to make any promises. But yeah, because that will not stick. I know that my mind is kind of very fickly sometimes. So it's not about fickle also. I'm kind of like against. I want to make it interested in this. It is interested in doing this particular problem, but it wants a more relaxed environment, I guess. But how, I can't play music that is copyrighted, and I have all the other those issues, right? I just want to chill and do this. I think for the last 10 minutes, I'm just wasting my time here. Anyway, yeah, hopefully I do this, and I will come back and show you the code how this is getting done. But also, this is I'm getting a mild. There is a panic present, right? Because I have to change the code. Yeah, I'll come back and do it tomorrow morning. In front, I mean, if I'm not able to do it alone today. Sorry for this, sorry for this, sorry for this, man. Guys, sorry for this. Bye, 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 bye.